In this video, we're going to take a look at systems of linear equations and how to solve them through substitution. This is a part of a bigger playlist. Make sure that if you haven't seen the beginning of that playlist, that includes how to find or what are systems of linear equations, you can check that out in the description below. Solving via substitution means that we want to substitute out a variable for an expression. So what we're going to look at in this section is solving via substitution. Now, this is different than solving via elimination, which was in the other video. To solve via substitution, we want to get one of the equations into a form that looks like a variable is equal to an expression. Most of our variables will be x's and y's, so we want to get y is equal to an expression or x is equal to an expression. Once I have that, then I substitute the variable in the other equation with the expression that it was equal to in the original equation. So if I have y is equal to an expression in equation 1, I will substitute the y out in equation 2 with the expression. Then we solve for the variable that remains. And then after we get the variable that remains, we use that to find the other variable, the one that we've eliminated. Let's take a look at an example and see how this is done. Our system is already set up for substitution because, as you can see, you have y is equal to 2x minus 8 as the first equation, and my second equation is 6x plus 5y is equal to 8. So in that first equation, I already have y is equal to an expression. This is what I want when I'm doing substitution. So when we go to solve this, what we are going to do is we're going to take the expression 2x minus 8 and substitute it in for the y in our second equation. So I rewrite the second equation, 6x plus 5y equals 8. And then I take out the y, and in its place, I put in 2x minus 8. Now, this equation only has one variable, and that variable is x. Therefore, I can solve that equation using the normal process. When I distribute the 5 and multiply that times 2x minus 8, I end up with 6x plus 10x minus 40 is equal to 8. I'm going to do two things at once. I'm going to combine the 6x and the 10x together. So those are like terms. That'll give me 16x. And then I'm going to add 40 to both sides to get rid of the minus 40. That will give me 48 on the right-hand side. If you need help with solving equations, obviously you can check out my videos on that as well. Dividing both sides by 16 gives an x, which is 3. Now I have the value of x. Once I have the value of x, I can simply plug it in to either my first equation or my second equation in the system and solve for y. Now, it's going to be easier to plug it into the first equation and solve for y because, as you can see, in the first equation, we already have y is equal to an expression. Once I know that x is 3, I just replace the x with the number 3, and you get y is equal to negative 2. So that means the solution to this system of linear equations is the point 3, negative 2. That's how substitution works. We get variable is equal to an expression in one equation, and then in the other equation, I replace the variable with the expression. In this case, we solve for x. You could have also solved for y. Once I have x, then I plug that in, figure out the y. Okay, let's take a look at another system. This second system has x minus y equals 3 and 2x plus y equals 3. In order to use substitution to solve this system, what we will have to do is get x equals an expression in y or y equals an expression in x. You can do so using either the first equation or the second equation. It doesn't really matter which one you solve for x or y or which variable you use. Now, obviously, there's going to be some situations where it's easier to solve for x, easier to solve for y, easier to solve in one equation, easier to solve in the other equation. In this case, a lot of them are very, very similar. So what I will do is I will take this first equation, the x minus y is equal to 3, and I will solve that one for x. It'll probably be easy to solve for x. If I add y to both sides, I get x is equal to y plus 3. So now that's my first equation. So I replace that first equation in the system with x is equal to y plus 3. My second equation in the system is 2x plus y is equal to 3. And now I can substitute. So in this case, my first equation has x is equal to this expression. So in my second equation, I'm going to replace the variable x with the expression y plus 3. That equation has one variable, so I can solve that equation for y. When I distribute, I get 2y plus 6 plus y equals 3. Combining like terms gives me 3y on the left-hand side. When I subtract both sides by 6, what I end up doing is getting a negative 3 on the right-hand side. Dividing both sides by 3 yields y equals negative 1. If y is equal to negative 1, I go back to this equation or this one, it doesn't matter, but this one will be easier. So I go back to my first equation and I replace the y value with a negative 1 and solve for x. This means that the solution to this system of linear equations is the point 2, negative 1. be careful that when you're writing the solution, you always want to write the x first, then comma, then the y. And by the way, the traditional approach for writing ordered pairs, x then y, would apply to other variable letters as well. You'll write those alphabetically. So if my variable letters were A and B, A would come first, B would come second. That's usually the case. Let's try another example. Here we have the system 3x plus 6y equals 12 and y equals negative 1/2 x plus 2. Those are my two equations that make up the system of linear equations. So this is nice in that my second equation already is solved for y. We get y is equal to an expression in x. So I can simply take that expression of negative 1/2 x plus 2 and plug it in for y into my first equation. Let's go ahead and do that. 3x plus 6y equals 12. That's the equation I'm using. Oh, that's different. A little bit bigger print. So replace the y with the expression negative 1/2 x plus 2. And then I go to solve. When I distribute that 6 times negative 1/2 x becomes negative 3x. 6 times 2 gives me a positive 12. You'll notice that my next step, I would combine like terms on the left. When I combine like terms on the left, my x values go away, and I end up with 12 equals 12. Now, this is a true statement. Obviously, 12 is equal to 12 in all circumstances. So what does that mean about this system of linear equations? Well, what that means is this system of linear equations has infinitely many solutions. A true statement yields infinitely many solutions. In other words, if you go back to the intro, these two lines are going to be right on top of each other. So the answer is infinitely many solutions. Okay. Let me just graph that so that we have that in our reference. Here I'm graphing on Desmos 3x plus 6y equals 12. Looks like this. Y equals negative 1/2 x plus 2. As you can see, the red line and the blue line, those two lines are the same. So every point on this line is also a point on this line. And therefore, since there are infinitely many points on a line, there are infinitely many solutions to this system. So when you end up with an answer where your variables have been eliminated and you get a true statement that's infinitely many solutions. By the way, if you would have ended up with a false statement, what would have happened is you would have had no solutions. If you had something like 80 is equal to 12, that would be a no solution case. Let's take a look at another system. Here we have two equations. The first equation is 2x minus 3y equals 10. The second equation is y equals negative x minus 2. Let's go solving this system using substitution. At first, we notice that one of the equations has y equals negative x minus 2. So it's already solved for y. That's a good thing. We take our other equation, and instead of inserting y into that other equation, we're going to insert negative x minus 2, because that's what y is equal to in the second equation. Then we can solve. Distributing that negative 3 gives me 2x plus 3x plus 6 is equal to 10. When you combine like terms on the left-hand side, you end up with 5x. If I add 6, excuse me, not add 6, let's subtract 6 from both sides. That'll give you a 4. There, dividing by 5, we get x has to be 4/5, or as a decimal, you can call that 0.8 or 0.8. Now that I know my x value is 0.8, I can use the equation that says y is equal to negative x minus 2 and plug in the 0.8 in for the x value. And in this case, we get a y of negative 2.8. And that's fine. That's my solution. My solution is the ordered pair 0.8, comma, negative 2.8. And that's all. Let's do one more example. In example 5, we have a system of linear equations in two variables. One equation is y equals x plus 2. The other equation is y equals negative 2x plus 8. Now you'll notice that both of these equations have y equals. That should not throw us off. In terms of substitution, it just means I have two options. I can plug in the expression negative 2x plus 8 into the y on the first equation, or I can plug in the expression x plus 2 into the y in the second equation. So this just gives us more options. All right, so I think what I'm going to do, since the first equation is solved for y, I'm going to take and write down the second equation. And I will replace the y in that second equation with the expression x plus 2, because y is equal to x plus 2 in the first equation. This gives me an equation with one variable. The equation is x plus 2 is equal to negative 2x plus 8. I will add 2x to both sides, giving me 3x on the left-hand side. And I will subtract 2 from both sides, giving me a 6 on the right-hand side. So I added 2x to both sides and then subtracted 2 from both sides. When I divide by that coefficient of 3, you get x is equal to 2. You can utilize either equation here. I will utilize the first equation. Something. I just hit something wrong. I hit a wrong button there and it magnified. So hopefully that problem is gone now. Okay. I am going to therefore, after I get the x equals 2, plug it in to either the first or the second equation. They're about equally as easy. So I will go y is equal to x plus 2, and I'll use that equation. I'll plug in 2 for my x and end up with y equals 4. So therefore my solution is the point 2, 4, or 2, 4. That's the solution to this system of linear equations. And by the way, we could have just as easily wrote the negative 2x plus 8 and plug that into this y when doing this originally. Moreover, I want to reiterate that if you ever doubt your solution, you can plug it into both equations and see that you get a true statement in both equations. That's an indicator that we have the correct solution. So if you want to check your work, you can check your work. So that is it for this video on substitution. All of our examples that we went through were like example 5, in that we only had 2 equations with 2 variables. In the next video that we'll see, we will look and find that we can do a similar process to solve for 3 equations and 3 variables. But so far, we've always dealt with 2 equations, 2 variables. Just a reminder again about substitution. When I'm doing substitution, I want to get one of the equations to be variable is equal to expression. I want to substitute the variable in the other equation with the expression. That will leave me one remaining variable, so I solve the equation for the variable. And the variable that I substituted out, I will use the numerical value I got to find the variable that I substituted out. That, in essence, is solving a system of linear equations using substitution.